Alright guys, today we're going to solve circuits problem 2.12. So this is the circuit they give us. It's got a single voltage source and then two separate resistors, 2 kiloohms and 4 kiloohms each. And we're going to find the current I flowing through the whole circuit and the voltage drop here, V naught, over this circuit. Alright, so first we need to draw an equivalent circuit. The equivalent circuit when the resistors are in series follows this formula. So for series, alright, the equivalent resistance is simply the sum of the individual resistances. So R1 plus R2 plus R3 plus etc. so on. So our equivalent resistance here is going to be 2 and 4 makes 6 kiloohms. So I'm going to draw the equivalent circuit here. We have one single resistor because these are acting in series, which has a value of 6 kiloohms. Okay. The way I know this in series is you can picture this like water flowing through a pipe. All right, these are all connected. These are like connecting two hoses together. It flows, or two pipes together, it flows through the same pipe or same hose. There's no junction where the water gets split or the electricity gets split off, like in parallel. So we know that's why I know these are both in series. All right, and we have a voltage source of 12 volts. So now we have a simple equivalent circuit. Okay, so our equivalent circuit. Okay, and to find the current in this equivalent circuit flowing through this one, we're going to again use Ohm's law, which we call is I equals V over R, voltage over resistance, to find the current. The voltage they give us is 12 volts. The resistance we have is 6 kiloohms, which is 6,000 ohms. So if we go to our calculator here, we have 12 divided by 6,000, which gives us 0.002 amps, which is the unit for current, which is equivalent to just 2 milliamps for our answer for our current here. Okay, so our answer for the current in the circuit is 2 milliamps, as you see here. Now, let's go ahead and calculate the voltage drop across the 4 kiloohm resistor. In order to do that, we're going to start with Ohm's law again, which we'll call as I equals V over R. Okay, we're then going to solve it by multiplying both sides by R, and we get V equals I times R. We then simply substitute in the I value for the whole circuit here of 2 milliamps and multiply it by just this individual resistor here of 4 kiloohms, not the 2, just the 4. That's the voltage drop across, we measure across this single 4 kiloohm resistor. So we plug in 2 milliamps, which we know is, we had before, 0.002 amps, multiplied by just this resistor, it's find its voltage drop, which is 4,000 ohms. Okay, so we do 0.002 times 4,000, so multiply this number by 4,000, and we get simply 8 volts. Okay, so that'll be our answer for the voltage drop across a 4 kiloohm resistor, which is 8 volts. We can check this and know this makes sense because of the 12 volt total we have to start with for our electrical potential, our voltage source. We have a 2 kiloohm and a 4 kiloohm resistor. So this would take up 1/3 of the total 6 kiloohms. And this would take up 2/3 of the 6 total kiloohms. 2/3 of 12 is 8, so we know 8 makes sense.